Hello, Sarah. Welcome. How's your day going? Yeah, it was raining here too. Or was that yesterday? That might have been yesterday. I don't know, the days are blurring together. But yeah. Oh, it was one of my coworkers sent a picture today, and it was hailing by their house. Like the whole street and driveway was covered in hail. I don't know what's going on. Yeah, the weather knows. I got a. I set up a filter on my in OBS. So hopefully like the typing doesn't like it's not booming anymore. Right? Like it's still probably a little, but not nearly as much. It's probably affecting my voice the tiniest bit too, but like just cutting out the bass a little bit. Yeah, I don't know. I think it's Tuesday, right? Yeah. Yep. If it wasn't working, I probably wouldn't know what day it was. Oh. Is there like a is there like a line getting sort of like chopping off a bit of this line of code? Hmm. I see that on John's stream too, and I think it's I don't know what it is. Like I have a 1440p monitor, so maybe when it tries to or when it does the I don't know truncation to 1080 or something. That's annoying. Oh well. You don't see a line like this line of code doesn't look like there's something weird happening, like it's getting squished. Huh. Weird. I mean, I can. That's what I see. But oh well, that's fine. So we're gonna do something different today. We're doing compiler stuff. Um, okay. Strange. Well, that's good, I guess. Maybe my monitor is the problem, honestly. This is possible. Why does this seem low? So I'm making up a programming language for fun, for learning. This is where it's at right now. Like you can kind of do your normal variable stuff. You can call functions. There's strings. You can take pointers and assign through pointers, and take pointers to pointers and assign through those. And arrays are currently non-functional, but we parse them just fine. Like these all work. And yeah, strings work. So these up here, these foreign procedures are so we generate C out the other end. So it takes all this stuff and runs it through, or it compiles it and then generates a bunch of C code. And then we just compile that C code and run it. So kind of sort of cheating, but it's good for getting a thing up and running. I mean, eventually, if I actually get serious about this language, then I could write like a custom thing to make it not have to depend on C or use LLVM or something. This is where it's at now. And these foreign things mean like, hey, these won't be defined in this language. Just trust that it will be there. So in the case of these, they're defined in the C, like there's a there's a bunch of stuff just written in C that gets pasted above the translation of your program. So we can write some stuff in C, at like the compiler level. So like print string is defined here, and that just gets pasted in when your program gets compiled. What are the advantages of creating your own language versus just manipulating what is already out there? One, to learn how languages work. You can gain a lot of deep insights into what a compiler actually has to do to compile your program and why it does certain things, and you can take advantage of that knowledge. Two, different programming languages have different features. So for example, well, there's nothing in here that's revolutionary, but in Odin, there's what's a good example? Maybe using is a simple example. So if you have, I'll just write some stuff here. So say I have something called like a guy. I have a guy. This is just like a template for a guy. So he has like a name, which is a string, which is just like characters. Maybe has an age, which is an integer. So this is our definition for a guy. So we can make a new guy and then do like g.name equals John, g.age equals 27, and then this exists in our program and we can do stuff with it. But sometimes you might want to, I mean, like if say say this name is like really long or something, typing the guy dot every time to do these things could be annoying. It's just a lot of typing depending on how big the thing is. Maybe you have like a bunch of dots or something. But in C you would have to do this every time, like the guy dot name, or like if you wanted to say, I mean there are shorter ways to do this, but the guy dot age equals, say you wanted to like add one, it was his birthday or something. Like this, typing the guy dot every time could be annoying. So what Odin lets you do is you can do using guy, and it pulls these names, like it lets you access these names without having to do, the guy. It lets you access these names without having to do the guy dot. So you could do age equals age plus 1, and then it'll just know to go through the guy, like it'll add an implicit the guy dot here, and that's just a feature of Odin, and it lets you do that. But C doesn't have that feature, so you can't do it. So different languages have different features that let you do different things. So if you have an idea for a feature that no other language has and you think you'd get some huge gains out of it, then maybe make your own language. There's another route you can take where, so say Odin didn't have this feature, this using thing, but I wanted it. Say I wanted it, but I didn't want to make my own language. I could write something, I could write a program that takes all of my Odin code and then generates the guy dot. And then like when I mean this is maybe not the best example for generating code, but since code is just a text file on your hard drive, you can generate text files with a program. So one way to get features that aren't supported in your language is to generate the code for the feature. But that doesn't work for all kinds of features. Sometimes you gotta make your own language. But I'm just doing it for fun, to learn. Welcome everybody else who's not chatting. I feel bad like spamming the Odin Discord with my stream links, but there's no streams channel, so. Hello, welcome. So I have a Trello. I made like just now basically, and then just kind of spat out a bunch of things that need to be done for this to be a usable thing, this language. I'm going to do subscripts first, I think. So array indexing. We currently parse arrays just fine and type check them and those kinds of things. But you can't like you have this A, you can't do that right now. Like that doesn't work. Not yet implemented. Yeah, look at that. So we're going to do this. We're going to do this today. Or at the start of today. I imagine we'll be able to bang through quite a few of these. Like if statements are easy. For loops probably easy. I mean while loops will be easier, so we'll do that first. Yeah, this one. Yeah, like most of the ones at the top here are should be pretty easy to do. Okay, so we need to make this work. The first step to making a new feature work is parsing it. So, gosh, excuse me. Somewhere in here is unimplemented. Here. So this is when we're parsing a postfix expression. So, I mean, any expression, like foo, this is an expression, right? You could imagine like a var x equals foo, and then foo is the expression here. So this is a fine expression on its own, but then foo might be an array, and you might want to be able to do that. So we need to parse this. I believe the foo would be parsed in parse base expression, which just handles like single word things. So like it could be null or true or false or an identifier, which foo is, or a number, string, or a parent. Right. So like something like this. Like this is valid. Just putting parentheses around. I mean, you might want to do something like that. Yeah, there's no error handling in the compiler right now. It's just like like if your types don't match, it just assert fails. Error handling comes when the compiler works more and the structure is a bit better or more fleshed out, we'll say. So we need to parse subscript expressions, which is pretty easy. Should be, anyways. That's what they all say. Well, no, there will be error messages at some point. I don't even know. I don't think my tokens even know where they are right now. No, there's not even like a file and line number for a token. We'll get there. Yeah, I don't know about that. Well, actually, Crest isn't even... Oh, geez, yeah. Yeah. Yeah, this isn't even Crest, though. This is like a different thing. I haven't looked at Crest in a long time. I don't know. It's good to start over every now and then, right? I mean, Crest was like my first... Maybe not first, but one of my first attempts at writing a compiler, so it's kind of janky. I have better opinions about how to structure things now. Okay, so to parse the subscript, we already have our base expression, which would be the A here. So now we expect a left, or well, okay, no, so yeah, we parse the base expression, and then if the next token is a postfix operator, like this right here, that's a postfix operator token, then we consume it. Don't message me on Discord. It's the BS bot, please. Lost my train of... Okay. It eats this token here, and then we switch on it. So if it is a left square, then we parse another expression, because in here it could be just a number, but it also could be like a well, let's just comment these out for now. It could be an identifier, right? So this should be valid, same as that. It could also be like some arbitrary like complicated thing, and that has to work too. So we just do I don't know, what's a good name for like the expression that's in here? I guess like index, maybe? Index. You just call parse expression. And then this will handle all of this. It'll like recurse down, and it could even end up in here, right? Like in here there could be another other array. Like it could be something like this. And this will just handle all that. And then we just expect a closing square bracket. And then that's it? Really? that's pretty much it. Okay, and then we just need to make another node. Subscript equals make node ast. Oh no, it is an ast expression, and then subscript dot kind equals expr subscript. Okay, so we'll have to make a struct for that. Index expression would be in there. Probably the left hand side as well, so like the array, which would be our base expression, right? And then we need to do this to return like we change, so our base expression at the beginning of this would be a, and then when we parse out this whole thing, we change the base expression and then return that up the tree. Right, ask expr. So here is all of our AST nodes, or well, this is all the expression nodes, and then here's some other AST nodes, and then like the base node. For subscript, it has an LHS, which is some expression, and it has an index, which is also some expression. Right? So we need to add this to the list of possible expressions. Okay, so now that we parse it correctly, we now get errors in the type checker, because we need to type check it. Yeah, right here seems fine. So if we're parsing, or if we're type checking a expr, what is it, subscript, then we type check the left-hand side, the array part of the expression, and then we type check the index part of the expression. We will make sure that the left-hand side, the type of the left-hand side, well, okay, hold on. Let's just be paranoid and make sure that it did indeed get a type. So make sure that's not null, and make sure that's not null. So now we need to make sure that the left-hand side of the expression is of type array, some kind of array. So left-hand side dot type dot kind type array. Assert OK. I mean, this, I should put this like everywhere. Like almost every assert in this file should have a to-do error handling. But this is fine. We'll need array. And then we will want to make sure that the index expression is of type int. Assert need int for index. LHS. I mean, ideally, I guess you'd want to be able to index with different kinds of things. So like this. Wait. Yeah. So the way that this is right now is this would be valid, but this would not be, because C is not of type int, it's a byte. Or if this was like I16 or something, that also wouldn't work. So we want to make a note to do handle different integer types by I64 or I32, maybe like U16, etc. All right. Does this make sense to people? If anybody's totally lost, please let me know. Sweet. So you can't use sized ints or unsigned. Correct. Not right now. Just integers. I guess like in the future there would be like some either flags Like maybe assert flags or like integer. Like I don't know. I don't know what this would look like specifically, but something like this, where like the type must be some kind of integer. That would be like the future plan. And you wouldn't want to be able to index with like floating points though, right? Like that would be madness. Indices. Yeah, proc with a big switch would also work. Yeah, like just I mean we have all of our integer types up here, so there could be like a is integer type t type bool if t is equal to, or I guess we could Odin something like this. Oh. Return true. Return false. Yeah, we could do that. Gets base type first. What do you mean? What do you mean? Like this would, I mean, in the code that we just wrote, I'd be like assert is integer type. Oh, if it's an alias type. If it's an alias type, the pointer will be the same. Oh, but if it's a distinct, right, like a distinct alias. Yes, that would need to be handled. I will leave this in here because I went through the hassle of writing it out, so that's fine. In fact, we now just support it, so that's fine. We'll put that like at the bottom. Yeah. Right, like, I mean, I don't even know what an alias type would look like in this language. Maybe, I don't want to use the word type def, but maybe, like, type def, my int, something like that, and this would probably make type B equals A. Alias B equals A. Well, so I think this would be like for a, because like structs don't look like that, right? Like if we have a struct, it's just keyword, name, the thing. So we want keyword, name, the thing. But an alias I'm thinking would be like that. Because an alias is just a constant that points at another thing. Yeah, alias as a keyword would be fine, but I mean, we could leverage the constant system and have it just work. Constant system of which there is none right now, but yeah, it's on the list. Pretty high up too. Like this will come soon. Okay, so now that we've done parsing and type checking, we now get errors in the code generator. It's always fun to implement new features because it like you have to bring it through all the stages of compilation in series. It's kind of fun to watch that flow happen. So we need to generate code for subscript expressions. Case expr subscript. This should be easy. We just print the left-hand side, and then we print open square, and then we print the expression, and then we print a closing square, and that's it. The Hello Sailor thing, I mean, probably everybody gets it from John, but John got it from, I don't know if it's Zork, but it's some like old choose your own adventure game thing. I mean, Hello Sailor. Yeah. In Zork 3, the adventurer must say "Hello, sailor" at the Flathead Ocean when the Viking ship appears to obtain the vial containing the invisibility potion. Wow. Hello, aviator. Yeah. I don't know, John, in a lot of John's like test stuff, he is making reference to stuff. Like there's, like the six, there are 63105 leaves in the pile or something. That's from another game. I believe the, like his go-to vector thing, 149. These are like the first three terms of some infinite series. Is it the Taylor series? Or something like that. Yeah, so the Taylor series, 1 factorial on the bottom here, 2 factorial, 3 factorial, this would be 1, 4, and 9. Yeah, John's big brain stuff for sure. Maybe this is coincidental. I don't think he's actually said where the 149 thing comes from, but this would be fitting. Okay, so I think we're generating code for it now. Runtime assertion. Okay, so check failed. Oh, expr subscript. So we've type checked all of the elements of a subscript operator or subscript expression, but now we need to like set the type of the expression itself. So array type. So we'll take the type of whatever the left-hand side is, and then the type of the subscript expression is the type that is an array of. Array type expr dot type equals array type dot array of. So like if A is an array of ints, then this whole expression would just be an int. It would return one int. If this was an array of strings, then this would be a string. There's also the addressing mode. And this is like, addressing modes is, certain things can only appear on the left-hand side or right-hand side of an equal sign. For example, it doesn't make sense to have a function call on the left-hand side of an equal sign. Unless you're in C++ and you return a reference, but we're not going to talk about that because that's madness. Generally, this does not make any sense. As well as like var thing equals like this, that doesn't make any sense. You can't take the address of a number because it doesn't make sense. Yeah, or if like 3 equals 3, like that doesn't make any sense. The reason is or I guess how you implement that, or the reason it doesn't make sense is because, like, yeah, we'll do this example. The reason this doesn't make sense is because 3 doesn't have any storage. It doesn't exist anywhere in particular. And same with this. You could maybe argue, like, oh, foo returns something on the stack, so that kind of has storage, but, like, you're not, if you do this, then you can't refer to it at all, so it, like, doesn't really make any sense anyways. Similarly here, yeah, like a number literal does not have any storage, so you can't take the address of it. But thing here does have storage, so you can take the address of it. So something with storage is an L value, and something without storage is an R value. And certain things have no value at all, right? So if foo, like if you did f equals foo, we'll get all these out of the way. If you did f equals foo, but foo doesn't return anything, then this doesn't make any sense. You can't do that. So that's why there's addressing, where is it in the parser? Yeah, so there's no value, L value, and R value. Those are the ones I have right now. And the result of a subscript operation is an L value. Yeah, because you could, like, you can do a like address of A2, like take an address of the second element. Like this should be valid, so a subscript operation returns an L value. That's correct. Unresolved identifier. Oh. What? So the B. Oh, well, yeah. Obviously. You have to declare your variables. Oh, that's one thing. Type. What? Type inference. I guess expected types is type inference. They're different enough. Okay. Look at that. Yeah, we got it. So this is the generated C code on the right-hand side, and then this is our code on the left. Done. I will uncomment these just so that they're still running, but they do not do anything. That didn't crash, right? Cool. All right, subscript done. Let's do, right, so this is something that's not strictly necessary. Having a little arrow thing, like if a function returns something, having this little arrow thing, it does just simplify the parsing a little bit, where in the case of, like if there was some directive here, how do I explain this? So if this was the syntax, then after the parameters, there could be an identifier, or there could be a caret if it was a pointer, like if it returned a pointer to int, or if it returned like an array of ints, then there could be this left bracket. And checking for those three things is just, in order to see if there's a return value, It would just be nicer to check for one thing. If there's this arrow thing, then we know to parse a return value. So I guess the directives aren't even relevant. I don't know if we'll do that. Maybe we'll do colon. Maybe. I don't know. What are people's opinions? Arrow or colon? I don't think colon is ambiguous with anything else. I think arrow looks better. It is more annoying to type, yeah, like having to do it's a 2-character thing where you have to press shift in between the characters. It's kind of annoying. Might go for the colon. Yeah. We will do that. So this should assert or something. Yep, unexpected token, colon. Parser, parse, proc. So this is the procedure that parses a procedure. Get the name, the parameters, and the return value. So yeah, see right here, like we check the next token, and if it's an identifier, a caret, or a left square, then we do this, but we could do if token dot kind is equal to colon. Eat the token, and then parse a type spec. So then we can delete this weird switch. This is just a little nicer. There we go. Int foo. We wrote int. Yeah, and this was a string. String foo. Perfect. Alright, I'm done. Maybe we'll write a procedures. Procedures. Foozle. Proc foozle will return an int. And this will just have some stuff in it. Return a plus b. I think we handle this right now. We might not. Result equals foozle. Oh, we don't have type inference, so we need to write that explicitly. We do not. Okay, so parse line 451. Oh, I bet when we're parsing a scope, we don't handle return values. No, we do not. Okay, so case. We will eat the return. And then if and we need to check if there's a semicolon. If there's not a semicolon, then we know to parse an expression. But if there is, then it's just like a simple. It's one of those. Do I have like a peek? No. Oh, I think I do. Like a peek where I can pass a thing. Peek kind, yeah. So if it's a semicolon, then we just need to, that's pretty much it, really. The node here is We do not speak of the variable. We cannot speak of the variable. Why are these not capital TV? Well, this second one looks to be the correct one. Or something, anyways. I don't know. It's a good meme for sure. Am I dark here? Should we do a little more? Oh. That's alright. Speak not of the variable. Right, so return node make node ask return, and then node equals node return node, I think. Too few arguments. It does help to pass the thing. Oh, peakkind just... Oh, peakkind doesn't return the token itself. That's probably fine. So we can just do if... Oh, we don't have an ask return at all. Wow. Ask return. Expression, expert. Peak is good. Peak is very useful. It's kind of goofy the way I do it. Like, I make a copy of the lexer, and then lex a token, and then, like, overwrite it with the old one. Cache the next token. Yeah. Like, I guess ideally you would do that, or you could do that while doing this. Oh, but you mean, like, so if I call get next token for the first time, your thing will lex 2 tokens, and then only return the first one, and then, like, do that continually? Oh. Oh, you, like, generate an array of tokens? Yeah, okay. Fair. Pointer to token. Do you allocate your tokens? Okay. Oh, I see. Like the lexer, or, Ah. Okay, yeah, I gotcha. Yeah. This one like sort of lexes as it goes. So if you get like a parse error right at the top of your file, it didn't lex the rest of the file. I don't know. I don't have strong opinions about that. Definitely. Peak kind I feel like should, so like peak returns the token and a bool. I feel like peak kind should probably return the token. I actually haven't seen this error message before. Two valued tuple found where single value expected. Interesting. I don't actually care about it, so. Okay, so if we didn't see a semicolon, then we know that there must be a proper expression. So, parse expression. We still have this, and we still have this. Okay, we gotta type check it. I mean, return statement. Don't save. I need to stop doing that. Wait. Yeah. Yeah, we're type check return. If there is an expression, man makes giant a day. Oh no. No way. That's a. Well, so most of this compiler I did write in like a weekend a little while ago, and it was running some generated VM code. So like there was also a VM, and it could compute like basically just like normal expressions. Like it handled like global variables and local variables, and you could call functions or I think you could call functions. Pretty sure you could call functions. Yeah, that probably still exists. Yeah, VM is just all commented out right now. And then like gen IR. Yeah, there's some code I'm not using, for sure. Going like full into the C backend for now, and then when this is good, then we'll do the IR and VM backend. It'll be a fun time. Type check expression. This expression. And then assert that it has a type. And the thing with return values is you want to also make sure that they match the return type of the procedure. And every node has a pointer to the procedure that it's in. So assert return statement dot enclosing procedure dot return type spec dot type equals this. I think we need a node cast here. Expressions, assert. We do need a node. What? enclosing scope. We also need an enclosing procedure. Parent procedure? Enclosing procedure. Guess we don't have that. Equals current procedure. Enclosing procedure. Proc. Right. Okay, so now this compiles. We type check the expression. Make sure that it has a type, and then make sure that it matches the type of the enclosing procedure. And if I think this is it for that. Yeah. And code generation. Case asked return. C print return. RAII? What do you mean? Where? I don't think so. The make node function? This is not RAII, I don't think. Whatever the Twitch equivalent of it is eyes. Somewhere. Oh man. I don't know. What did it say? Like, what do you even mean by that? Like, up here? No. Type check node? I think we were looking at this. And I just added this. I don't know, man. I believe this to be correct. Print return. Okay, so these don't need to be like that. They can be like that. Or maybe this goes. There we go. All right, print return. I don't think we have that. So for this code generation stuff, we just pass around like a string builder to a bunch of different functions, and then they append stuff to it. This one in particular will print, let's be print the word return. And if return statement dot expr does not equal nil, then we want to print that expression to the string buffer. String builder. Strings.builder. We also want a space. And then out here, we want a semicolon. Oh, hey! Yeah! I've been trying it out the last few weeks or so. I've done a handful of streams. How's it going? When we parse a make node ask return, we need to eat a semicolon. Expect a semicolon. Hey, that's great. Yeah, I mean, hard to be too good in these times, but you know, we make do. That's good to hear. All right, I think it works. Return. What? So this is incorrect. That's wrong. We'll fix the new line for sure. Okay, new line. This does it's supposed to have an expression on it. Why? Why is there no expression? Oh, wait, do I? Ah. You have to set the variable, of course. Of course. Nice. And then we'll haven't actually ran it yet, so we'll do that. Print int result. So we'll make this something. So we should get a 25? Run the C compiler, and then run the thing. Oh, I added that to the C code. That's wrong. Print int result. 5. Look at that. Perfect. This needs a big ol' header. Hey, neat. We will do one less new line. Oh, wait. Cool. Sweet. All right. And then just as a test, if we put in the wrong thing, right? So a string doesn't match int. This should assert fail. And it does. Perfect. All right. Return statement done. This is done, but it was actually turned into a colon. If statements. I will push this though. I don't think I've pushed in a few days. So there's a lot of whole lot of stuff. Whole lot of stuff. Very good. Hey, Jake. This is not Mathy Game, it's true. We're just doing a side thing, you know? Wow. We're about to do if statements is what we're gonna do. So we don't currently have if statements. Basic, we'll just have a ifs are bad though, yeah. Yeah. Anti-if. Yeah. This is just compiling to C, yes. Currently. Currently. I guess variables are basic stuff, but okay, so we want if statements in our program. They introduce problems. Yeah, that's true. Yeah. I mean, yeah, they are often a failure point. It's true. Yeah. I brought this up on stream before, but like this is just the stupidest thing I've ever seen. Use objects to build a code that is flexible. Yeah. Look at, oh no. Oh, the ifs. Pretty scary, huh? Oh man. No, I'm pretty sure this is like a real thing. Like, yeah, no, branching, no. You can't branch in your program. It's just, I mean, it makes your code impossible to read. Like, you can't even type anything anymore. I mean, like, this use objects to build a code that is flexible. Like, this hints to me that it's satire, but I'm really not certain. Weekend spent debugging. Alright. Okay, so for ifs, do we want parentheses? That's the part that I don't know. Well, people have weird opinions about other things. Genuinely, like, I don't know. Like, don't use pointers or whatever. Well, yeah, it's for sure. They like objects, but like capitalizing the O and like write a code. I don't know who says a code. I don't know. It's doesn't seem real to me. Parentheses are, yeah, I mean, it's kind of, so the thing about parentheses that I do like is that the condition is aligned with the next thing, the next line, and like, I mean, sure, these can be different or whatever, but like, it's just kind of nice that they're aligned. If there's no parens, then you have this kind of thing. But I also don't know, like, so, because we want to be able to do like this kind of thing, where you can do a statement and then a condition. So I don't know, like if thing colon equal, I don't even know what this would look like. Oh, I guess having var makes it really easy. Foo bar foo greater than 2. So like this or like this. Should this go in? I don't think this should go inside it. Like if we have parens, then it would probably go like that. Assuming, yes, I do assume 4-space indentation. You'll notice, oh no. Convert indentation to spaces, yes. 4 spaces. Yeah. Yeah, this looks reasonable to me. Because then that makes it easy, like you can... Like, I don't know in Odin if you can just do whatever you want for the statement part. Like if I have foo and it's a proc, can I just do if foo and then like 1 greater than 0? I can. Okay. So this doesn't have to be a variable declaration. Right. I don't know how you would parse this. Like maybe... Like, can you... Expected an operand. Yeah, this seems tricky to parse, but maybe not. Maybe not. But yeah, we will do parens. We will do with parens. Var foo int is 5, and then print string foo is greater than 2. If foo less than 2, then we will assert false. And then this will never get written. So this will not work. That's a weird way to say if is not implemented, but sure. So the way keywords work in the Lexer right now is when we're scanning for tokens, if we hit like a letter, then we scan an identifier, and then we iterate through a list of predefined keywords, and then if the identifier matches that keyword, then the token is not just an identifier, it's a keyword. And that mapping is done down here. So we will put if, and while we're at it, we might as well put like else here. May as well. And then if and else are not defined yet. So let's comma. Alright. Just start with the same error. Not yet implemented. If, yeah, okay. I don't know why the parser is on the... Yeah, we're going to move this around here. Well, no, we'll leave it. Parser is on the right-hand side of the screen. So if it's an if, then I think, do we eat it? We do eat it. Expect, we won't implement the, like the pre-statement thing yet. We'll just operand, we'll just do the simple thing first. And then expr colon equals parse expression. So this will be the condition, call it cond even. Expect closing paren. And then parse a scope. Scope colon equals parse scope. I don't know if we need to eat the curly bracket before. I think we do. Like, what does parse proc do? Parse body. Okay, so parse body handles the curly brackets and then returns the scope. We will use that. Oh, struct uses that as well. Okay, sure. Parse scope. Except not parse scope. We want our call to scope. Parse body. If statement. node asked if. We don't have an asked if, so we'll have to make that. If statement dot cond condition equals cond. If statement dot block equals scope. There's like so many different words for the same thing. Like scope, block, body. I should really like settle on one. Maybe they're not the same thing, really. I guess maybe we shouldn't use block. Maybe we should use body. But then like if you're in a function, like you have some code, and then you just like open a scope, is this, I guess this is just a scope? Yeah, it's not a body, right? We will use body, and then I'll make a note to block body, turn all blocks into bodies. All right. All right, we need an asked if. If has a condition, which is an expression, has a body, which is a scope. It's fine. That's fine. Okay, so we parse it. Now we need to. Oh, it's giving me. We'll type check it first. Asked if. Type check if. We will need to do else as well. But just doing the simple thing for now. Type check if statement. I want to call this variable if, but I can't. Somebody's making noise outside. We will type check the condition. We will assert that the condition has a type. Somebody is like banging a drum outside. Degenerates. Fair enough. Fair enough. We will assert that the condition has a type, so it doesn't equal null, and then we will also assert that it is a bool. And then we also want to type check the body. Type check scope. If statement dot body. Yeah, those are some loud drums. I'd be careful with those. That's with like inverse square drop off too. Like you'd be deaf for sure. Good. Very good. Very good. Is the mic good? Like it should be less boomy now. I mentioned earlier in the stream, but I put like a high pass filter or like an EQ thing, and then like drag the low end down. So like my typing shouldn't be as loud, but it's also affecting my voice a little bit, cutting out the low end. Yes, it's good. Nice. That's good. Very nice. Very nice. So we need to we need to generate code for if statements. Print of if. I want if to be above, actually. Yeah. Strings.builder if statement. If space paren c print expr if statement dot condition sb print sb close paren space. Does print scope shouldn't put in the curly, I don't think. It does not. So things that call print scope have to do this. Oh, they also have to like increase the indentation level. I'll just copy all this. So we print the closing thing and that, and then indent level, print the scope, minus the indent level, and then indent for this. Procedure should be if statement. Need to pass the string builder. Body, not block. Not block. Okay, that compiles, so this should work. And it does. So then if we run this, we should get this message, and we should not assert fail. Foo is greater than 2. And then if foo is 0, we should assert fail. Wait. Oh wait, no, that's the wrong thing. Foo is equal to 0. I don't know if I responded. I'm glad it sounds good. That's good. This is good news. Okay, and we did assert fail. Good, perfect. Cool. Nice. Okay, so we have some if statements. Now we need an else. Print string. Foo is not less than 2. So we want to get this message and this one. After we parse an if, wait. Oh, I'm being weird about how I do this. I do want, like, so I mean in the code generator there's this like top level thing that just checks the thing and then calls a procedure. I kind of want that for parsing as well. We'll move the line comment down to like here. That's like a weird one. So return would be node equals node parse return. Wait, what am I doing? Return statement. Return asked return. Okay, so yeah, we can kind of What am I doing right now? Hold on. Tonight is a drum STD. So in here we should, right, we expect a return, and then if it is not a semicolon, then we will parse an expression. So I'm just kind of going over, like, sort of simplifying this code. That's, nothing really new is happening here. If it's not a semicolon, then we parse an expression, and we do a return statement dot expr equals expr. Return statement. Right, return. Right, and then parse if if I want if to be above return. Expect lexer if node equals node parse if lexer. How many projects are you actively working on these days? Too many. It's really stupid. There's this compiler. I have the Game Jam game that me and my buddy are continuing to work on, which I think works. Should work. Yeah. So this also working on. Well, this is that's right. So compiler, game, and then the engine is kind of separate. So that too. And then just like other little things that it strikes me to desire to work on, like on the weekend or something. I'll often try just making something small or fiddling with I don't know, writing like a JSON parser or like I don't know. These are all my projects. I think that's like the main three though, actually. The UI editor that I started last stream, that's going to be on the back burner for a while, but which one is my favorite? The engine. Yeah, the engine's like my main project for sure. The game is fun too, but the compiler's also fun, so yeah, I don't know. Engine's first, and then the others are tied for second, probably. Do you work on stuff aside from work things? Does this look the way that I want it to look now? I think so. Yeah, that's nice. Yeah, full-time Jenga effects. Very nice. Yeah, games are fun. Yeah, you should do it for sure. You say you miss making games. Did you used to make games? I forget. We might have talked about this actually. Magic the Gathering. Oh, geez. Yeah, that's like one thing That's one of the things that I've tried not to get into because I know that I would like go hard on it for sure. My buddy in the Dr. Professor in the chat, he does some magic stuff. Oh, he's not here anymore. It's fine. That's fine. Fortunately, made a handful of hobby games. Yeah, nice. That's cool. In like C and stuff, or did you use like a off-the-shelf engine? Mostly C. Cool. Nice. That's cool. Yeah, games are fun. It's yeah, you get to just kind of come up with interesting ideas and then like try them out and see them like happen. It's a very stimulating kind of development. I have a buddy that I used to work with. He went to web dev from making games, and he's like, man, making games, I never realized it, but it's like crack compared to like making websites or whatever he's working on. Just because like it's very flashy, very visual, like super. There's a good feedback for making games that you don't really get anywhere else. Even like making a compiler is fun, but like there's no like your interface is this. Like, oh well, okay, well hopefully you don't get error messages, but it's not a very visual thing. But money, yeah, I mean money, right? Lots of money in web development for surezies. For surezies. Okay, so there's two ways that we can handle an else statement. You can do, we're going to do it this way for now, but I will explain both. If after we parse the procedure, or after we parse the body for the if there's an else, then we'll just eat it and then parse another body. Else body. Colon equals parse body. Lexer. I guess it's not specifically with parsing else, but else if. So, like we can basically when you have this and then like this and then something like this, what's happening here is basically this. It is the same as that. But I guess that's semantically different, because then you wouldn't be able to have this else. So maybe else if is like a, yeah, this is, yeah, okay, never mind. What I was about to explain is not actually true, because you can't do this. That was just something that was in my mind for how to parse else ifs, but yeah, no, it looks like, okay, so then we'll have, hey Jesse, welcome. We're going to have an array of else ifs, which are just a bunch of ifs, right? That makes sense. Do we recurse? Can we recurse here, I wonder? I think we can. If we hit an else, then we eat the else. If we hit an if, right, so like an else, we're in like an else if now, then we could parse an if. So like this function is now calling itself. then we'll append that to else ifs. Else if. But this should be like a for loop, because there could be many else ifs. So for and then if what would be the way that we stop? Papavadi. I'm on your phone now, not on your left monitor. No, I'm using the like the Twitch stream manager window now. Before I was just using like I was on the page for my stream, so the chat was on the right, but in the stream manager the chat's on the left. But maybe I can move it? I can move it. But I don't trust it to like remember where I put it or anything like that. So I'm just gonna leave that. Yeah, y'all are over here now. You should make a game. Do it. But definitely leave me on in the background. Bottom of the right monitor. What? No. Bottom left of the right monitor. Okay, so we're parsing else ifs here. We'll name this loop. If we don't hit an else, then we know to break the else if loop. If we hit an else and then don't hit an if, so this is an else if, and this is just an else. We know that at the end of this, we need to break the else if loop. Is your engine ready for you? Oh gosh, no. It's barely ready for me to use, or barely in a state that I can use. Well, actually, that's not true. I mean, it's like we used it for a game jam, and like we didn't really have to change the engine much. There was like a weird bug, but for the most part, we were just like writing game code. So I mean, some point maybe this year it'll be like a usable thing that people can use. Need documentation, like a good way to do documentation. That's a pain, but yeah. You demand finished tools. It'll come. It'll come. Hold your horses. Finished engine 2020 confirmed. Yeah. Yep. You can mark my words. The engine will be completed in 2020 for sure. So else block is just not block. We're doing body. We're switching to body. I wrote block again. Body. It's an asked scope. So if it's an else, then we wait. Yeah. Okay. No, we've already eaten the token, so we can just do body else body equals parse body. And then we break the loop. So that should be correct. Right, so we should get this message and this message now. Well, actually, we're not doing anything with these. Right. Append if statement dot else ifs if statement dot else body. So we want these two. Ast if. Slice of ast if. Yes. Probably. That should be fine. Should be fine. Oh no, it needs to be a... Okay, so now we will probably... Why is that not showing up in... Oh. We need to type check it. Ast if. Type check if. For else if in if statement dot else ifs. Type check if. Is what I'm doing not going to work? I think this is not going to work because in if foo else if bar else if baz. When we get to here, we're recursing and calling parse if, which will parse this if, but then it'll also try to parse this one. So we can't do that. We cannot do that. Yeah, no, this cannot happen. This cannot happen. Do we actually need like an ast else if? That sounds silly. We could have like a parse single if, which only does this part. We'll try that. Parse single if. Single if. I guess this could be like a local procedure. Right, so none of the else ifs will have else ifs in them, which is a good thing. Yo, Brendan, what's up? Just an Odin tip. Get some food, Jesse. You can avoid OK for peak kind. What is that? I don't understand. Foo enum with like an empty thing? Yeah, I would need to see some like... But what do I do with that? Like, is token... Would token kind have a... Like, would that be in token kind? Right here? I do that? And then I can here kind equals nil, and then I can do kind equals dot if kind does not equal nil. That's craziness. I mean, probably neat, but I don't know, I like the comma okay. I like the comma okay. It's there is a lot of things in Odin that can be nil though, like a type ID can be nil. Like T type ID here, T is equal to nil. Oh, I mean, so yeah, like peak would, yeah, like just these wouldn't be there, and then so this would be like T equals peak kind, T does not equal nil. I don't know. I don't know if I like that nil is like for non-pointer things. Seems weird. Type ID is uninitialized. Nah. 0 is initialization, Jesse. Come on, dude. Yeah, that is a cursed line of code. Don't do that. Don't write that into a computer. For sure. For sure. Okay, this is correct. But we need to type check the else ifs. That's right. Okay. We can recurse here without having like a type check single if, because just none of this stuff will run for an else if. That's fine. Undeclared name if statement. Oh. Oh, it's root. Nah. If statement. Type check else if, and then if statement dot else body does not equal nil. We'll type check scope. I like performance. I should write a performance-oriented language. It's just, I mean, like Odin is a performance-oriented language. Maybe not as fast as raw assembly, but I don't think. I think there will be inline assembly though. I think Bill wants that. So you could drop down to that level when you need to. This should work. But we need to generate code for it. Print if. Okay, so we don't want two new, we don't, well. We will not, we will just do this, the one with a one new line, and then for else if in if statement dot else ifs, C print if, else if, so that'll print all of, oh, but it won't. We need to print the else. And we need an indent. And then if this stuff. Scope, else body. Hate casting to slices. You don't cast to slices. What do you mean? I mean, you cast to slices if you want to like turn a string into a slice. But, I mean, it's fine. You just type the word, cast. Or transmute, or whatever you do. I think I transmute them, but you might be able to cast them, I'm not sure. You got a problem? What was your problem? Right, so then we want to print the last new line, or a second new line. Bar. Oh. Well, we'll get another thing in here. Else if foo is greater than 10, this should not run. Foo is greater than 2 and less than 10. Foo is this correct? And this should be like pretty much the same code except the strings here. No! What is this new line? We do not. I don't, like when people do this with their else ifs, like have like a new line. Nah, dude. Absolutely not. Oh. Maybe we don't want this one. So the problem is like the else if goes into here, prints itself, none of this runs, and then it prints another new line. So maybe each of the else ifs will print a new line. Wait, did that? Okay, but I do, No, they do not belong there. Absolutely not. And I went back to a project I did a node, and I had a string, and I had a gematria int. I don't know what a gematria is. And wanted to simply make an index in the string a specific letter such that string index equals I'm not sure what you mean. Like you had like this? You wanted something like that? Cannot assign to... Oh, yeah. Right. Strings are immutable because this would actually corrupt this string in the data segment of your program. And then when the second time that this procedure ran, there would actually be like a 5 in here already. And that's no good. So if you want to do something like that, then you have to do like bytes colon equals transmute slice of bytes. But do know that you are, if you did this specifically, then you are stomping on stuff in the data segment. So you might want to do this. or like tprint or whatever. Do you like when a text automatically reads in a text file if it's changed and gets rid of whatever you had there? I do, because I can also I can undo it as well, which is it's just nice. Yeah, that's good. Gematria is like A equals 0, B equals 1, C equals 2. Like just like incrementing. Why gematria? Am I even saying that right? What is that? Alphanumeric code of assigning a numerical value to a name. Huh. Oh, it's like a cipher thing. Gotcha. Gotcha. Yeah, I don't know. You'd want to do this. Because you cannot change strings because doing that is weird. It's weird most of the time. Like you don't often do that. Okay, so I need to fix this this new line thing. There should be a new line here. But if I put it here, then we get new lines in the if. Oh dear God. No, this is unacceptable. Alright, bye Jesse. Enjoy your tacos. And what happens if there's another one? You won't, okay. Oh, that's also acceptable. No. It's because I'm recursing here, that's the problem. Maybe I will just accept this. But now this has a dumb new line. Hold up. Hold up. Okay, this is wrong as well. What? Oh, yeah. Yeah, there we go. It's not ideal. I want a new line here, but that's fine. That is fine. And then we can run it. That's not the file. That one. That one. Right. So we get foo is greater than 2, and foo is greater than 2 and less than 10. Sweet. If statement's done. While loops? While loops. We're going to actually use while, not for, like Odin. While var x equals 10, x is greater than or equal to 0, we will print it. We'll make it 5. Add a new keyword, while. Ah! Hello Foxify, welcome. We are doing compiler stuff. Very fun. I think so. Alright, if it's a while, then we parse a while. Oh, that's cool. That sounds super neat, actually. That's a fun project. I like that. How's that going? Yeah, no, I bet. Okay, cool, neat. You'll be able to like make like a sort of a ROM thing and then like draw pixels and do that kind of stuff. Make sounds, take input. Yeah, that's cool. Yeah, that's neat. Emulator is a project I'd like to do. I haven't done one of those. But yeah, making your own, like an emulator for a fantasy console that you create. That's cool. That's a neat idea. I like that. Parse while. Ah, speaking of L values and R values earlier, this needs to return a thing. Ask while needs to exist. Condition, same as a if, just an expression, and then the body. Almost wrote block again. We're calling them bodies. Okay, parse while. We eat the while token. We expect a paren, and we're going to expect an r paren at the end of it. Condition is parse expression. Wasn't born in time to create a competitor. Yeah, unfortunate. Unfortunate. We parse an expression, we eat the right paren, and then we parse a body. And while statement. While loop. While loop. Make node ask while. While loop dot condition equals condition. Condition. While loop dot body equals body. Return while loop. Alright, that's great. This is like super simple. And we need to type check it. Type check a while loop. So we need to type check the condition expression. While loop dot condition. We will make sure it has a type. Assert $nil, and then we will assert that that type is equal to bool. And then we also type check the body. I think that's it. Should be it. And then we need to print it. C print while takes a builder while loop. The same body stuff that we're doing already. I'll take it from here. Is that it? Does that just work? X minus equals 1. Do I do minus equals? Yeah, I don't think I do. X equals x minus 1. Hey, 5, 4, 3, 2, 1, 0. Nice. While loop's done. Easy. Should bring this minus equals higher in the list of things to do. For loops. Should I do for loops right now? Should be easy enough. We'll do for loops. Add another keyword. For. Parse for. Last for. What do I have on my clipboard? Lexer.for. So fours are going to look like they do in C, probably. So for. One other thing. Optional var. So in certain cases you don't need. So the reason we want var here in like a procedure body is because it's harder. It is just slightly harder to know to parse this. Having a var there makes it like super easy. Like you know what you need to parse. So here you need var, but for example in like procedure parameters you don't, because you know that anything in here will be a variable. So like this should be valid, and like var can be optional here. Similarly, in a for thing, in a for loop, you know that the first thing is going to be a variable, or maybe you don't. I don't know if C actually enforces that. Maybe you can write like any statement there. I'm not sure. but theoretically var is optional here. Well, if we enforce that it has to be a variable, then it's optional. But a task for another time. I equals 0. I is less than 5. We'll do less than 6 because we're printing 0 to 5 inclusive there. Or 5 to 0, I guess, inclusive. We don't have plus equals, so I equals I plus 1. Hey, welcome back, Foxify. Zero idea what you're doing. Yeah, I don't know either. You need a VM, which is pretty easy to do generally. It's just like, it's pretty much just a big switch statement, and then you do like, so we have a VM here. You switch on the kind of instruction, and then you fiddle with some registers. Or maybe you have a stack machine, and stack machines are even easier. Super straightforward. Z80 submodule. That's done for you. So what is it, like a library? Git submodules. Oh, I see. Okay. Interesting. Well, good luck. That sounds fine, I guess. Yeah. Is the Z80 like super complicated? Like would Z80 GitHub? Oh, it's like I see. It is a CPU. Oh, it is a single .c file, so that's good. I respect that. Okay. 1,600 lines. Wow, holy crud. Look at all that. What on earth? Interesting. What is this instruction macro? Holy. Neat. So this is our for loop. We will have to define asked for. I don't know what like these are generally called, these different parts of a for. Let's call it like a pre statement. I don't know. Maybe we'll enforce it to be a variable right now. No, we don't want to do that. Pre statement. This can be any node. There's the condition, which must be an expression. And then there's like a post statement, which can be, which has to be a statement. Yeah. Parse for. Alright, so we expect the for. We expect an L paren. And then later we'll expect an R paren. Pre-statement equals parse state. Oh. So parse scope is actually the only thing that we have here. We don't have a parse single statement. Huh. Let's just see what this looks like if we do factor that out. Statement, parse single statement. Hmm. And then pretty much just this goes in there. What's weird is maybe comment. Well, that's fine. I think this function will skip comments and then just like try to parse another thing. So in here there will be a statement loop. And this will be in there. Hello Jesse, how was your taco? Tacos. However many you had. If not okay, then we return nil. Or like assert false. Because you shouldn't run out of statements. No, you return nil. And then the caller can decide whether that's okay or not. We don't. Parse single statement. That's it. Just to make this code compile. Right, so up. No. Up here is the problems. Append nodes statement. Maybe this should be statements. If statement is equal to nil, then we break. Otherwise, we add it to the thing. We do break, actually. Right. And here, we will just return the thing. If we hit a curly, we return null. Do we need to eat the token? Hold up. Wait. What happens with this, the closing curly bracket? Who eats that? Who was eating that before? Break the node loop. Oh, no, that's fine. Yeah, because then like if it's parsing a procedure or something, then that would eat the curly bracket, and that's okay. That's fine. If it's a comment, then we continue statement loop. Turn node assign. Turn node assign that. Right, then out here, like if it was a comment or something, then, or no, this should be unreachable. Unreachable. Should never get there. Oh, eating now. You were just getting the tacos. Gotcha. I'm home. You inspired me to... Whoa, you left your house? How dare you? Do you know what's happening out there? I mean, rewrite my conflict. You had a config language? Which? Have you used Cell at all? The one Bill has? It's alright. Alright. That's allowed. Let me get a beverage. I will be right back. Didn't go that far. Non-essential travel count if it's not that. I don't know. I don't know what the rules are. I just don't leave the house. Except maybe like go to the grocery store like once a week or something. Or less than that, ideally. You don't like Odin's string stuff. I don't understand how you could not like it. If it makes you feel better. Yeah, it's possible, yeah. I keep getting like shipments from Amazon, and it's from China, and I'm pretty choked about it. Alright. Cheers. I got a Philips 78 Kolsch. It's a good one. It's a good one. Got Coke. You don't have beer? Dude, there's places here delivering beer. I don't know what you're doing. It sounds... Didn't you get the memo? It's like quarantine. You just drink beer to make the pain go away. Dihydrogen monoxide. I got some of that as well. It's pretty alright. Sticky icky. Ah, highly potent ganja. Nice. But it's not illegal here, though. Yeah, but we don't know that. I don't know what I'm gonna do with the whole hair situation, man. It's getting long and weird. Maybe I'll hit up my barber. See if we can do like a private session or something. Ah, it's so noisy, man. I think it looks fine. Thank you, Sarah. That's very nice of you to say. For now, also, yeah. Yeah. I mean, even like doing it this morning was, well, this morning. I did it probably like 4 hours ago. It was all, I don't know, it's weird. It's hard to manage now. Yeah. Hippie schwa. Yeah, I'll get like dreads or something. It is cold in my house. Let me make sure no windows are open. Long haircut. Getting along with it. Yeah, no, like it's like the hair is designed for a certain length, so like you can't just add length and have it work. It's not gonna work. Well, yeah, I mean, if you already have long hair, then it's no problem. Dude, what happened to your H? Got like cut in half or something. I'm still cold. I'm grabbing a blanket. Oh, is hair removal? Tooth. Yeah, blanket stream, dude. It's a very comfortable blanket, also. Though, should be more kind of. I mean, maybe I should just like wear pajamas or something, but whatevs. Moo. Guys, making me Google everything today. What is a moo? Wait, do I even want to Google this? That sounds like. I don't know. Those look like sundresses or something. We are parsing. We are parsing for loops. Or something. We were doing this. Right? Yes. Parse. CA is the, yeah. Not teach you all. Well, I don't know. What is a moo? Should I be taught what a moo is? Yeah, California can get bent for sure. What? Yeah. It is a sundress. Yeah, that's what I said. A grandma sundress, gotcha. Yeah. Well, there's the whole, like, I mean, there's some political movement for Cascadia exit, which is just like the left or the west coast of North America, Cascadia. And I don't know, I guess they want to separate, like a Brexit situation or something. No, no political movement for sundresses. Though, I mean, you do you, I guess. If you're passionate about sundresses, sure. Cascadia Subduction Zone, is that what it is? Oh, maybe that's where it gets the name from? Or maybe, I don't know. But yeah, generally like the left, I keep trying to say left coast, the west coast. That sounds hot. Well, oh, nice. Okay, I get it. Nice, that's a good joke. Very nice, Sarah. Oh, subduction, that's like when, that's like, yeah, it's a convergent plate boundary. So like it would be hot. It's like kidnapping? Oh, the seduction zone. Fair, yeah. Oh yeah, the megathrust. The megathrust earthquake. What's the megathrust earthquake chance? BC. 12% chance of a huge megathrust earthquake in the future. 9.0 on the Richter scale and 20-meter high waves. Seducing the megathrust, yeah, exactly. Yeah. Look at this cat. Hi, kitty. Oh no. She is pretty. Oh yeah, she's precious for sure. She's such a cutie. You can't stay here. My keyboard is there. Yeah, she's needy. So needy. So needy. Huh? Okay, kitty, you gotta go down. Come on. Secret shopper asks people that if you are social distancing. Oh, like kind of like one of those people that like a food inspector would kind of do. Like they'd go and like secretly go to a restaurant and then like, or they do that with like liquor. Like if they see you not ID somebody, they'll bust you for it. There's a fault line like 100 miles off the west coast running from Alaska down to Sacramento. And they expect there would be earthquakes, but there are none. And there's evidence of very large earthquakes dating back every... Yeah. So like that's the megathrust, right? Like, yeah. Now, if the megathrust came now, oh my god, what a disaster. That would be horrendous. Like the I'd be choked for sure. Yeah. No, the megathrust, yeah. We in Victoria are very aware of the megathrust and our looming doom. I don't know why people live here, honestly. Why am I here? Like, it seems like such a bad idea. Like, if we just know that this earthquake is probably coming. Why am I here? Housing will be cheap, yeah. 2020, just a year of horrible disasters. BC is very beautiful, but like, I mean, I could be in BC, but not on the island. So like, I don't know, like even Victoria's like kinda cuddled in, where like Seattle kind of comes, like there's sort of like a channel leading to Seattle, like this ocean is like out here, and then there's like a channel, and then Seattle, and then Victoria. So like there's a bit of a buffer, so maybe we wouldn't get too destroyed. But it's very good when we get little earthquakes, because then the bigger one won't be as big. So whenever we get an earthquake, it's like, yes, victory, because just a little one is totally manageable. Yellowstone, oh geez. That's a huge one. That's like the whole thing is a what's it called? I forget the word for it. But I remember reading in Short History of Nearly Everything, they were like looking for where the fault would be in Yellowstone, or where the something would be. Caldera, is that it? I don't know, they were looking for it in Yellowstone and couldn't find it, and then they realized that the whole thing was what they were looking for, which is just insane. That's ridiculous. I'm not even sure exactly what that means, but yeah, okay, it is the Caldera. Okay, well, let me Google it so that I know, like, what... Oh, okay, so it's like a cauldron-like hollow forms after... Okay. Yeah. Right. Giant crater. Gotcha. Why don't they just drill for it? Okay. We need to... Where were we even? We're parsing ifs. We're parsing fors, actually. Parse single statement. Does this handle the semicolon? It does. Maybe this shouldn't handle the semicolon, because you don't want to like have to put a semicolon right there. That's stupid. But we're going to do that. So, seems fine. The condition we need to eat the semicolon. Do the... Perfect. I expect. No. Wyatt. Oh. L? Nah. The entire West Coast is a lost cause? Oh, jeez. Oh, Lexpect. Gotcha. Clever. It is a pun. Well done. That's crazy though, Dithinus. That's wild. If you do find it, do link it. Okay, so we have these things, and then we do the paren, and then we parse a body. For loop equals make node asked for loop dot pre statement equals pre statement. Condition post statement. Return. I think that's it. So yeah, this does require a semicolon right now. Make this not require a semicolon at the end. Maybe. I don't know. Yeah, it's on like the Ring of Fire, so like I guess that's a bad thing. But like, yeah, 12% chance that it's supposed to hit in the near future. Yeah. I'm not too concerned. Definitely a little concerned. Yeah. It'd be scary for sure. So many buildings downtown are made out of brick, and they're just gonna like liquefy. If it's like really bad, and it hits Victoria hard, oh, done. Like not even close. Type check for loop. I don't like that type check return is getting far from if. Proc. Struct. Proc. Type check for loop. I mean, pretty much just all of this stuff. So, type check node for loop dot pre statement post condition and then assert the condition has a type and it equals bool, and then we type check a scope. No body? Ah. This does need a body. And then we generate code. Again, return should be with the proc there. Return should be with proc print for SB pointing to a string builder strings dot builder. Wait, so Jesse, what don't you like about Odin strings? I don't understand. What's wrong with Odin strings? For loop. For. Show me again how I need to. Oh. Stir. Hello. Bytes is you transmute to a slice of bytes. Bytes 2 equals 3. B. Heblo. Heblo. Maybe cast works here, not sure. It does not. You need to transmute. I don't like that, I want it to be one line. Typing is not the bottleneck when programming. Like you want your language to be designed, to have a good design, not to be fast to type. And there are other things that in Odin are much more brief than they are in C. So like, sure, this is like more than it would be in C, but also, given this string, you can do for thing in the string. And in C, you'd have to like for, like I don't even know, I mean, we do that actually in the preamble. Yeah, you'd have to write out like a whole thing. Why not both? Because of the thing that I outlined before, where like, if you did do this, like if you say you had something like this, say you did this, right? First time this procedure gets called, say this passes, and then does this, so it puts the B in there. The second time it gets called, that B is still in there because this string lives in the data segment. Even if this doesn't run, this will still print Heblo the second time. Like that's, you want to be explicit when you're doing weird things like that. This is why a lot of languages just straight up have immutable strings, like you're not allowed to change them. What? You want that to happen. Like if you have this, and you optionally stomp on it, the next time this is called, even if this doesn't run, you still want the B there? Surely you would not. Unless you're doing like even if you do want that, that's like the most specific use case, and it should not be easy to do that, because that's like the very uncommon case, but could result in bugs, because most of the time you don't want to do that. What do you mean, well, yeah, as though it's obvious? You're fiddling with the string in the data segment. Like that sounds crazy to me. And yeah, that's a good point too that Bipunski says, where if you have this, well, I don't know if the Odin compiler does this. I don't think it does. But then up here you have another one. If your compiler interns these to the same string in the data segment, doing this will stomp on this one as well. is madness. It's madness, I tell you. Strings that aren't literals, you don't have that problem, no. But you would still need to transmute the thing, because that's how the type works. But like changing strings is not something you often do. So it's fine that it's a little less brief. I mean, you can even write like set stir at index. There you go. Right. It was on the heap. What do you mean copied it over? Well, yeah, like that's not... The problem isn't the literal, it's that that's how the string type works. The compiler doesn't like... The compiler can't know whether something's on the heap or not. Also, the heap is imaginary, but that's a separate thing. Anyways. Node for loop.pre statement. Why isn't something like this in the standard library? It probably is. The heap is imaginary, so is the stack. Woke gramming? We're doing woke gramming over here. I'm not imaginary. I'm not imaginary. I don't know if... Oh, this might print a new line as well. It's definitely going to print a new line. So our for loops are going to look stupid. Maybe not stupid. I guess Casey does them that way. Is that it? Unexpected token. Does equals operator work on strings in Odin and make a shallow copy? No. No, why would it make a shallow copy? You can still index strings, but you can't assign... is that... Pretty sure that's true. Stir string x... Oh, this is... Stir b equals stir. Yeah, you can still read it, but you can't assign it. You don't know what half of Odin does. That's fine, yeah. But no, like a string equals. This is what it does. If the lengths are different, not the same. If the length is 0, then they are the same. Because they're, yeah, right. And then string compare is just a memory compare with Yeah. I'd like better Odin documentation, but it still changes. It's really not changing that much. We just need people to do documentation, because I'm sure Bill doesn't want to do it all. We need like an Odin by example or something. That'd be really good. Yeah, that'd be a good thing to have. Read the source code. Yeah, read the source code of the compiler. No, but reading the source of the core library is like, that's a good way to figure out how things kind of are. Okay, what was this complaining about? Unexpected token X. Where? No. Nobody told you to read the compiler source. That would be madness. Yeah, no, like reading the Odin core library is just, it's fantastic. Like that's, yeah. Yeah, I almost don't believe that. I'm like quite certain that they probably meant read the core library. But yeah, I don't know. I'm not going to hold an opinion on that. Okay, hold up. So here's a cool thing, cool Odin feature. Parse line 98. Oh, did I? Hold up. Oh, I wrote somewhere else. Where did I? Oh! Stupid. Stupid, stupid. Hey! Okay, we're gonna have a weird looking for loop. Oh, that's so bad. That's so bad. Right, so we need to, after printing the condition, we need one of those. Maybe we'll indent. Yeah, we'll go Casey style. We'll do it. God, looks so terrible. Okay, so print node is going to have a parameter for doing a new line. We don't want new lines here. Print node, do a new line. True. Okay, so yeah, we already have the new line and for var, but it also for semicolon. Yeah, semicolon, new line. These could probably be the same thing, but I'll keep them separate. Oh, but now I gotta like add this to everything or a bunch of stuff anyways. Yeah, I mean, I'm pretty sure all the flags are in like main.cpp. Thing.odin. Okay. Alright, Jesse. What do we got? What are we doing here? String. Make byte. Len. Buffer scan. Okay, so this here, this will allocate memory, and then you immediately stomp on it. So this is going to leak. Yeah, I imagine, I figured that was the same thing. But this is going to, yeah. What part of it wasn't compiling? This, probably? Yeah, so you would do the thing that I showed, like bytes equals transmute slice of bytes buffer, and then you do that to the underlying memory of the string. Do you... Right, well, I mean... I won't change your casing. But, so I don't understand... Oh, see, this is why you don't do tabs. Tabs, not even once, for sure. Or, did you even? Oh, maybe you didn't. Yeah. Okay, so... Are you intending to do a copy of the message here? Is that the idea? Okay. So, buffer equals strings dot clone message bytes equals transmute byte buffer scan, so like a scan exists, and you want to return a string, presumably? Disk space. Nice meme. Yeah, no, I center justify my code. No white space. Just center justified. Yeah. Yeah, this is how I program usually. I just thought since I'm streaming, I would use a proper or a program or text editor. But yeah, this is the correct way to program as far as I'm concerned. Is the first thing in the string structure the data? It is the data. Yeah. So if you look at the core library, you have raw string, which is a data pointer and the length. And you'll notice that a string and a slice are pretty much the same thing, just slightly different, but the same enough. So yeah, you would clone the string, transmute it to bytes so that you can change the thing, and then since bytes points to the same thing that buffer does, you can just return buffer and it'll have this change in it. Dear God, so loud. Okay, okay. I'm not gonna watch that right now. I've been trying to do for loops for like an hour, I swear. I know. I'm sorry, Jesse. Odin will make you happier if you learn it, I assure you. Do you want me to send this to you? Here you are. Okay, this is like really stupid. Right. False. All falses. Here we will print our own thing. Right, so for this, I've decided we are combining these. Yeah, 'cause we only ever call them with the same. Hey, victory. What was our thing? Right, we have a while loop, print string, while loop. Or loop. Alright, I'll see you later, Dithinus. Have fun. Aww. Look at that. That's pretty cute. That's pretty cute. Oh, I didn't. What do you mean? Oh. I'm missing all my semicolons. Nice. While loop. 5 to 0. For loop. 0 to 5. Just need to remove that semicolon. But that's fine for now. Yeah, otters are pretty cute. Pretty cute. For loop's done, I think. Pretty sure. For loops. Yeah, I think that's it for today. Got a lot done. We got these 6 things done. Pretty productive. Things work. Pretty happy. Pretty happy with it. Yeah. Yeah, I'm good. I'm good with this. Gonna end the stream now, I think. And then chill before bed or something. Thanks for coming, everybody. As always. I hope you all have a good rest of your night. I'll see you around.